So we continue with exercise 7.6, question number 11. X cos inverse x upon root 1 minus x squared. Here you must have noticed derivative of this is already present here. So we take this as a substitution. Put cos inverse x equals to t. Substitution, remember. Differentiation. You know derivative of cos inverse x is minus 1 upon 1 minus x squared dx equals to dt. You don't want minus sign, this becomes dt here. So minus sign will go that side. So here if I come to integral, minus sign is already there, this minus sign. This become dt here. This is t at this place, cos inverse. And you need x. What is x? That is cos t dt. Fine. What is x from this? You know x is cos t. So the now entire integral reduced in form of t. Now we know how to do by parts. Product of two functions. Use Lecture rule to decide u and v. Now this is a combination of algebraic and trigo. So algebraic occurs first. So this should be u and this should be v, remember. So we do by parts now. So by parts integration here. Minus sign is already there outside. T will come out. Integral of cos t here. Minus inside the integral derivative of t with respect to t, which is 1, into integral of cos t and then whole t. Okay, so this is equals to minus t into, what is integral of cos t? You know that it is nothing but here sin t. So this is sin t minus, here inside the integral this is sin t dt. Sorry, this is dt. Okay, now here further minus t sin t. What is the integral of sine? Now it is minus cos, so this become cos t, and finally plus c. So we get here, I'll take minus sign inside here. So minus t sin t minus cos t plus c. But your final answer should be reduced in form of, you know, x. So here t is cos inverse x. So this is cos inverse x. What about sin t? You don't have sin t, but you have cos. So I'll write root of 1 minus cos squared. So it will be x squared minus, what is cos t, which is x plus c. This is the required integral. The conversion to a variable x is very important, remember. Here t is cos inverse x. You don't have sin t, but you do have cos t. So I'll write sin t as a root of 1 minus cos squared. But what is cos? That is cos square t. But what is cos t? That is x. So you have root 1 minus x squared. Minus cos t is x plus c. That's question number 11. Question number 12 is very simple. You have x into sec square x. There is a combination of each two functions. We call Lecture rule, combination of algebraic and trigo. So this should be u and this should be v. And do by parts, not a big task, remember, because you know integral of sec square. What's integral of sec square? 10. So use that concept and continue. Okay. Question number, I'll take next 13, which is a single function, tan inverse x dx. So you know in such questions what we do? We write into 1 and we use integration by parts. Now single function is always u, remember. So this is u and this is v, remember. Or use Lecture rule, you will realize. This is inverse and this is algebraic. So this is u and this is v. Now we do by parts, integration by parts. So tan inverse x will come out by parts into integral of 1 minus inside the integral derivative of tan inverse x here, which is 1 upon 1 plus x squared into integral of 1 here, and then the whole integral. Okay, so this is tan inverse x into here x minus this is same here, so you have x upon 1 plus x squared dx. Now to solve this is always important task, remember, in integration by parts. If you just observe it, it is linear upon quadratic. So we set the derivative. What's the derivative of this one? 2x. So multiply and dividing by 2. Now this is which form? F dash upon f form. Remember, this is f and this is f dash. So you can integrate very easily. Tan inverse x into x minus 1 by 2 log of mode. Mode is not important because here 1 plus x squared is always positive. Tan inverse x into x minus 1 by 2 f dash upon f, which is log of mode of denominator expression. Question number 14 at this place, which is here x square plus 1 into log x. So combination of which two functions? Algebraic and trigo. Recall the Liet rule. This is algebraic and log function. Combination of algebraic and log. Log is always u, the other one is v. Remember, log comes first. So I'll use integration by parts here. If I use integration by parts, so by parts I'm integrating here. Log will come out, log x outside, integral of x square plus 1 minus inside the integral differentiation of u, that is 1 upon x into integral of x square plus 1 and then whole dx. This is what integration by parts. Now you are clear with this. Okay, so this is log x into what's integral of this? X cube by 3 plus x minus here 1 upon x as it is. This is x cube by 3 plus x and then dx. This expression as it is here, log x into x cube by 3 plus x as it is, you need to simplify this. So 1 by 3, 1x will get cancelled, x square plus 1, the whole dx. So this is log x into x cube by 3 plus x minus 1 upon 3 as it is. Here integral is x cube by 3. This minus will go inside, so minus x plus c. So this is the last step now. Question number 16 here. E raised to x sin x plus cos x, the whole dx. Now, if you just remember this formula, e raised to x fx plus f dash, the answer to this integral is e raised to x into fx plus c. This is the required integral here. So this is f, derivative of sine is cos here, f dash. So answer to this one is e raised to x into sine x plus c. Now here next question, question number 17. So in the 17th question, it's just based on this formula only. So let me just write question number 17 here. Integral of e raised to x into x upon 1 plus x the whole square. You keep e raised to x on a side, remember. Keep e raised to x and aside. Now, you know, in integration we always try to set the denominator expression into the numerator. So I can rewrite here x plus 1 minus 1 upon 1 plus x the whole square. What I've tried here, I've tried to set this expression over there. Now this is equals to, inside the integral you just do individual division. If you do individual division, these upon this, which is just this much, minus 1 upon 1 plus x the whole square. What I did, first I have set this expression over there by adding and subtracting 1, and then I did individual division. Now you know that here d by dx of, by chain rule, 1 upon 1 plus x is exactly minus 1 upon 1 plus x square. This is by chain rule, you know it. So this is f dash. So therefore, what is required integral? That is e raised to x into fx. That is this one plus c. F plus this is derivative f dash. So e raised to x into fx plus c. Next question, question number 18 is really good question. So, integral of e raised to x 1 plus sin x upon 1 plus cosine x. Now in such questions, whenever usually if you have e raised to x and if you cannot do by parts, we always try to set f plus f dash inside the bracket. So for that, what I'll do, I'll reduce this one into a single function. You know that this is 2 cos square x by 2. 1 as it is. So this should be reduced into half angle, twice sin x by 2 into cosine x by 2. First, I've reduced the denominator expression into a single term. So you know this is the double angle formula here. This is 2 cos square x by 2. Just recall this. Cos square x by 2, that is 1 plus cos x the whole by 2. I have placed this value, you know it very well. Okay. Now do individual division. Immediately you will realize, if I do individual division, these upon this, that is half 1 upon cos square, which is sec square x by 2, plus here 2 will goes away, 1 cosine will get cancelled, so this is just tan x by 2. Individual division, 1 upon this and this upon this, so this is equals to e raised to x. Oh, now you are through, I think. This is nothing but f. Do the derivative of this one by chain rule, so you will get exactly this much by chain rule. What is derivative of tan x by 2? Sec square x by 2 into derivative of x by 2, which is 1 by 2. So therefore, you got the final answer, which is e raised to x into fx, which is tan x by 2 plus c is required integral at this place. Question number 19, that is e raised to x into 1 upon x minus 1 upon x squared. This we already done in question number 17. Clearly you can see that this is f and this is f dash. So what's final integral? E raised to x into fx, that is 1 upon x plus c. Okay. Question number 20 here, that is integral of e raised to x. I'll write first x minus 3 upon x minus 1 the whole cube. So what we do, as I explained earlier, we set this expression over there. So here e raised to x I'll write minus 1 minus 2. I'm just setting over there upon x minus 1 the whole cube. Now you must have realized. Okay, so this is e raised to x, individual division. This upon this, so you're left with 1 upon x minus 1 the whole square. This upon this, so one factor will goes away. Minus 2 upon here, minus 2 upon x minus 1 the whole cube. Now the only thing you need to check whether derivative of this is this or not. So let's check that. So here d by dx of 1 upon x minus 1 the whole square. So how do we do this? This is in the numerator. So you have minus 2 into x minus whole square minus 2 minus 1 into coefficient of x, which is 1. So you are getting minus 2 upon x minus 1 the whole cube. So that is f dash. So this is f dash. So therefore the required integral is e raised to x into fx, which is 1 upon x minus 1 the whole square plus c. This is the required integral. Okay. Next, question number 21 here. Let me call I equals to e raised to 2x into sin x dx. So here product of two functions, so we need to use product rule. Now you just recall the Lie combination of exponential and trigo. Exponential is always last function, so this has to be v and this has to be u. You see, trigo comes first, then exponential. Okay, so now by parts we'll do integration. I've just called this as I. So u will come out, sin x will come out into integral of e raised to 2x minus inside the integral differentiation of sine, derivative of sine, you know it is cos x, into integral of e raised to 2x and then the whole dx. So you have sin x into e raised to 2x upon the coefficient of x, which is 2, minus this cosine x as it is into integral same what you have written there by 2, this dx as it is. So here you have 1 by 2 into sin x into e raised to 2x minus this 1 by 2 being constant, you can keep it outside. So you are getting cos x into e raised to 2x dx. Now again you are getting product of two functions. So there is no other way here. You need to use integration by parts again. Using integration by parts again for this part, remember. This one I am keeping as it is. 1 by 2 into e raised to 2x into sin x as it is minus 1 by 2. You know, like that question, this is u and this is v. We are repeating this procedure. Cos x will come out. Here let me write by parts we are doing. Integral of e raised to 2x, now writing directly e raised to 2x by 2 minus inside the integral differentiation of cos, which is minus sine, so this become plus, remember, into integral of e raised to 2x, the same that you wrote outside. So e raised to 2x by 2 and one outer dx is there still, remember. Okay, so now here let me just rewrite e raised to 2x into sin x. Here if I open the bracket, this is 1 by 4, half, e raised to 2x into cos x. This minus, so you have 1 by 4. And this is inside this, you have sin x into e raised to 2x dx. Now this reduced to the question itself. You see, that's the same as the given question. So this become I. So 1 by 2, at least from this 2, okay, let me write as it is right now here. This is 1 upon 4, this is given question, that is I. You are interested to find the I, so I'll take this I on the left hand side here. So this become I plus 1 by 4I equals to, this is as it is. You can keep it as to 2x if you want outside. 1 by 2 sin x minus 1 by 4 cos x. Now this is how much? You know, 5I by 4 equals to e raised to 2x into 1 by 2 sin x minus 1 by 4 cosine x. So therefore you want I, so 5 will go that side by 4. So e raised to 2x, I'll take 4 by 5 inside the bracket. That 5 will come down, so here upon 5, 4 I'll take inside the bracket. So twice sin x minus cos x. I'm sorry, here plus c everywhere. This is c. Here also plus c, and if you do this, this is also plus c. Next, question number 21. That is here integral of sine inverse 2x upon 1 plus x squared. Now we already studied inverse trigo functions, so you must have noticed that this is the formula of sine 2 theta. So here obviously you need to put x equals to tan theta substitution. The substitution is what? X equals to tan theta. Okay. Now once you take the substitution, differentiation. So dx equals to sec square theta d theta. So therefore I means above integral is sine inverse 2 tan theta 2t upon 1 plus t square into here sec square theta d theta. So this is simply here sine inverse of sine 2 theta, you know this, into sec square theta d theta. So we are getting 2 theta into sec square theta d theta. Now this is one of the earlier question. Keep 2 outside and use integration by parts. So I'm keeping 2 outside. This is theta sec square theta. You can integrate this very easily. So this should be v and this should be u, and we use by parts. This is algebraic, this is trigo. You see your algebraic comes first and then trigo. Okay. So now we are using parts here. So 2 as it is. Theta will come outside. Integral of sec square theta d theta minus inside the integral derivative of theta with respect to theta 1, integral of sec square theta, and then whole d theta. Okay, so here 2 as it is, this is theta, integral of sec square is 10 minus, this is 10 here, tan theta d theta. This is 1, integral of sec square is 10. And finally last step, you know integral of 10, which is log of mod of sec theta plus c. Integral of 10x is log of mod of sec x. Now important part is reduce into which function? X. So we are reducing in form of x now, reverse substitution. 2 as it is. What is theta? That you can write tan inverse x into tan theta, that is just x, minus now log of sec you need to write from tan. So as x equals to tan theta, You know 1 plus tan square theta is sec square theta. But tan theta will be your root of 1 plus x squared equals to sec theta. So sec theta will be root of 1 plus x squared plus c. What you did here, just you have obtained the value of sec theta from the substitution. If you want here one more step, you can write like this. Take 2 inside, 2x into tan inverse x. Here this 2 and this root 1 by 2 can take into the product. So 1 by 2 into log of 1 plus x squared plus c. So 2 will get cancelled. So 2x into tan inverse x minus log of 1 plus x squared plus c. What I did here, see, I have used the property of log function. This is log of 1 plus x squared raised to 1 by 2. Root means raised to 1 by 2. And that 1 by 2 I have written here in the product. So therefore you have this 1 by 2. This 2 is from inside the bracket. And therefore it reduced to this finally. So final integral is here 2x tan inverse x minus log of 1 plus x squared plus c. That's your final integral. MCQs 23. That's very obvious. You know here how to integrate. What we do? This is not linear, so e raised to x cube cannot be integrated. The only way is put this equals to t. So 3x squared into dx equals to dt. So therefore x squared dx equals to 1 by 3 dt. So this becomes dt. One by 3 I'll keep outside. This is dt and this is e raised to t. You know what is the integral of e raised to t? It is just e raised to t. So e raised to t plus c. But what is t? That is x cube plus c. That's required answer. 1 by 3 e raised to x cube plus c. That's probably option A. The first option is the required answer. Go to next one, 24 number here. Question number 24. Let's see that. Integral of e raised to x into sec x into 1 plus tan x. So here e raised to x is there, so you need to recall that result. Take sec x inside the bracket. So sec x plus sec x into tan x. So what you observe, this is f dash. E raised to x fx plus f dash. What's your answer? E raised to x into fx. Fx means sec x here. Plus c. That is nothing but option B. Now following are some questions for you. You must try by parts or based on this formula. The one is integral of, let me write here, for example, sine of log x, the whole dx by parts. All are based on integration by parts, remember. One is this. One more, integral of sec cube. This is really nice question. One more, same way, integral of cosec cube. Fourth, let's write integral of x into cos cube x dx. Fifth one, let's see one more here. cos inverse 1 minus x square upon 1 plus x square. This we did earlier. You need to take some substitution, you know. We had a same question. One more here, sixth one. Let's see integral of x into sec squared x into 10x dx. How we'll do this? I'll just give you hint. You take this as a v, entire this as a v, and this as u. Because this you can integrate very easily. You just think why you can integrate this very easily. You know the integral of this sec square into 10 integral, you know very easily. So take this as a v, this as u. 7. Same way you can have this question also. X into cot x into cos x squared. So same way you take this entire as v and this as u, and you can do by parts. One more here, let me write next. The next question is here, eighth one, integral of x raised to 2, that is x squared into 2x. This is straightforward by parts. The first one is quadratic, that is the algebraic, and the last one, second one is, you know, it's exponential. This is always v and this is u, remember. Okay. Try these also. E raised to x into cos x dx. This you can do, not a big task. Okay, and one more here, 10th question. That's integral of sec inverse x. You can write into one and you can do by parts.